About 47,600 fraud cases have been reported in Ghana since 2024, and about 58 million Ghana cedis worth of funds have been stolen from mobile money users. This increases up to 33% every year, year on year, accelerating. These aren't statistics, these are people. Mobile money was born in Africa. It changed everything. 1 billion people, their first financial identity. But the security layer underneath, built on SMS in 2007, SMS was never designed for authentication. Meet Kwame Mensah, a small business owner who lives in Accra with a balance of 4,200 Ghana cedis. And then on a corrupt shop employee swaps Kwame's SIM at 3 a.m. By 4 a.m., the fraudster has his OTP. By 5 a.m., Kwame has nothing left. Meet Kofi Asante, a gig driver at Cape Coast, where his phone is in his pocket and his OTP has actually left town. A scammer calls and claims he's from MTN, and Kofi reads out the verification code to the scammer. 2 minutes later, a withdrawal opens in Accra, which is actually not feasible due to the location of Kofi Asante. That is about 165 kilometers away. Here, Kofi never moved. Now, in the advent, 500 Ghana cedis was stolen and the fraudster never left the phone. Now, let's meet Ama Asante. A teacher in Kumasi, she lost her phone, replaced the SIM card legally, and she did everything right. And she did everything in a legitimate way. The system can't tell the difference as to whether it's fraud or not. So, it treats her like a criminal. Here, Ama has been suspended for 3 days. She has to visit the branch. Now, in joining the queue, that's 2 to 3 hours. And with all these, it leads to one broken layer. And here is what almost nobody knows. Every time your phone gets connected to a network, the network already knows it's you. Not 6 digits, not OTP, not a password. The network has always known. We just never had access to it. Until now. Introducing Nokia Camera Open Gateway Network Intelligence APIs. We decided to use these metrics or these particular endpoints, which is SIM swap detection, device identity, location retrieval, network tenor, number recycling, device roaming, as well as device reachability in order to build our product. Already deployed by every major MNO, and nobody used it like this. We are introducing AkomaID, a product that closes the gap, a product that adds security. Without further ado, this is going to be the live demonstration, which involves 3 scenarios of the Nokia Camera API for Kwame Mensah, Ama Asante, and Kofi Asante. Now, for Kwame, AkomaID does its real-time analysis. SIM swap is true, device change is true, network tenor is false, number recycling is false, location proximity is also false, device reachability is true, device roaming is false, AI assessment is also false. Now, in the advent of this, when we produce that particular risk score based on all these particular endpoints, we provide an enum, or we provide a value for it being critical. And once it's critical, we tend to block that particular client. Now for AkomaID, AkomaID does its real-time analysis, checks whether SIM swap is detected, device change, network tenor, number recycling, as well as location proximity and device roaming, with device reachability as well. Now we make all the checks and we realize that all are bringing in false values, and we provide a risk score as a result of the accumulation of these false values to allow the user make a transaction. With Kofi Asante's case, AkomaID does its real-time analysis on the SIM swap, does it on the device change, as well as the network tenor and number recycling. Now with location proximity, device reachability, and device roaming. Now, you realize that device proximity is having a very high value. The reason is because the location at which the transfer was made was different from the location at which our legitimate user is. And as a result, AkomaID blocks this particular transaction to enable the user go through these particular layers that we have applied within our architecture. With these 3 layers, each having its own job. With layer 1, we verify the number. Over here, there is no SMS, no typing. This replaces the SMS OTP for 75% of our users. Layer 2 consists of 7 Nokia camera APIs, all working in parallel to ensure that results are provided in the nearest possible time. And our third layer is the face liveliness with Know Your Customer recovery. And this is going to happen in the next 60 seconds. And with this, no fraud detection, the replacement of the broken layer. With the broken layer, 1.4 trillion transactions, 20 million Ghana cedis, what one MNO spends on SMS OTPs every year. 60 times return on investment for an MNO deploying AkomaID. This is not a niche security product. This is infrastructure for a $1.4 trillion market. This is the composable pricing based on the layers you need. AkomaID auth costs $0.005 per call. This replaces SMS OTP. AkomaID signals cost $0.02. AkomaID identity costs $0.03 per API call, and AkomaID recovery costs $0.05 per call. AkomaID is a commercial packaging of the Nokia camera APIs. From Nokia camera, AkomaID API provides a layer of abstraction between Nokia camera and the telco providers. And with that, 58 million Ghana cedis is protected. Every AkomaID API call is a Nokia camera API call. Here, Kwame's money is going to be saved with our system. Here, Amma proves who she is in 60 seconds. And here, Kofi's account locked before the fraudster tries to reach the counter. The network already knew. We built the product to listen. AkomaID, powered by Nokia Camera Open Gateway, built at GSMA Hackathon for 2026. For more info, visit us at akomaid.io. Thank you very much.